Okay, the second half of 6.4 is going to be the synthetic division, the second method of dividing. Many cases you're going to get your choice. If you like long division, you're more than welcome to continue using that. If you like synthetic division better, you can start using that after we see it. It's important to know that synthetic division cannot always be used. Okay? So looking at it, okay, synthetic division can only be used if you are dividing by a polynomial in the form x minus a. Okay, because that a is very important. That a is what we're going to be looking for. Now, if it's not divided by something x minus a, you are going to have to use long division. So take your time and think about the problem before you start just plugging away, writing stuff down. If it says you can use synthetic division, make sure it's in the correct form first. Okay? Now again, that a is very important. So think about when we took out things for the vertex and vertex form in chapter 5. All we want is that a. It's x minus a. So when you're looking at what you're dividing by, think about that when you pull the a out. Okay? It's just the value of a, not the minus sign in front of it. So here we have x cubed plus 2x squared minus 6x minus 9, and that's divided by x minus a. Looking at x minus 2, which is x minus a, so it is in the correct form. Now the a, it's not negative 2. Our a is just the 2, so a equals 2. Now the way we're going to set up this synthetic division, it's almost like an upside down long division bar, and we're going to put our a on the outside. Across the top here, I'm just going to list all of our coefficients. Starting here, we have 1, 2, negative 6, negative 9. Now the bottom down here, this is where our new polynomial is going to show up. Okay? The first thing I'm going to do is bring down that first term there, which was our 1. That's going to be the first term in our new polynomial. Okay? That's why it's important x minus a has to be the form, because that x having a leading coefficient of 1 makes this possible. Now the steps we're going to do here, you're going to multiply and then add. And you're always going to multiply that a by the next term that's going to be in our new polynomial. So in this case, 2 times 1 gives us 2, and then we're going to add. 2 plus 2 is 4. Next we're going to take that 2, multiply it by 4. 2 times 4 is 8. And again, I'm going to add. Okay. Negative 6 plus 8 is 2. Keep marking down the line. 2 times 2. 2 times 2 is 4. Add gives us negative 5. You just keep doing that until you're down to the end of your polynomial. Now that 1, 4, 2, and negative 5, that becomes the coefficients of our new polynomial. Now, what I like to look at, or how I like to look at it, I always start the right-hand side, and we have remainder, constant, x squared. And that's the term of each one of them. And if you just keep going, if there's more terms there, but always start at remainder and start working your way down. So if I'm writing out this polynomial, 1x squared plus 4x plus 2, and we have our remainder. We're going to write this the same way as the long division, negative 5 divided by x minus 2. Right? So again, start with the remainder and work your way down. Remainder, constant x squared, x cubed, x to the fourth, however many terms you have. Okay? So once you pick out the correct a, as long as you can multiply and then add, you should be able to get all your coefficients. Just take your time, watch your signs, and do the work correctly. Okay? So I'm going to erase this. Let's do another example. Okay? Here we have a much bigger problem here. X to the fifth plus 3x to the fourth minus 2x cubed plus x squared minus 5x plus 2. And here we have x plus 2 is what we're dividing by. Now our a this time, remember, x plus 2 could also be written as x minus a negative 2. So our a ends up being negative 2 this time. So when I'm setting up this problem, negative 2 on the outside as our a, and we have 1, 3, negative 2, 1, negative 5, and 2. And now Same work as before, so I'm going to move through this pretty quickly. I'm going to bring down my first term, and I'm going to multiply. Negative 2 times 1 is negative 2, and add. Gives me 1. Negative 2 times 1 is negative 2. I'm going to add, gives me negative 4. Negative 2 times negative 4 gives me 8. Add gives me a 9. Negative 2 times 9 is negative 18. Put that down here. Negative 18 plus gives me negative 23. Negative 2 times negative 23 gives me 46. Add gives me 48. And just like before, I'll start at the end. We have remainder, constant, x, x squared, x cubed, x to the 4th. 1x to the 4th plus 1x cubed minus 4x squared plus 9x minus 23 plus 48 divided by x plus 2. So the same steps. Bring down the first one, multiply and add. Multiply and add. Okay, so as long as you keep multiplying and adding correctly, you should get the coefficients for our new polynomial. Okay, a little bigger, but the math shouldn't be that difficult. It's not very complicated math as long as you know the steps. Okay, the remainder theorem. If a polynomial p of x of degree n greater than or equal to 1 is divided by x minus a, where a is a constant, then the remainder is p of a. What that's saying is we have a new way of evaluating. We can plug in our value of a here. Remember what evaluating is, just plugging in that value in for the variable and simplifying it. Well, what this says is if we do synthetic division, whatever the remainder is going to be the evaluated form. Okay? So the problem here, p of x is x to the 4th minus 5x squared plus 4x plus 12. What is p of x when x equals negative 4? Well, this is basically asking us p of negative 4. What if we take that negative 4 and plug it in for x, what would it simplify to? The remainder theorem is another form of how to do this, or another method of evaluating. The negative 4 becomes our a, and now we're going to set up our synthetic division just like we did before. Now pay attention to this. It's x to the 4th minus 5x squared. It's missing an x cubed. Since it's missing that cubic term, we still need to put fillers in, and this is the same for all synthetic division. You have to have everything going in order. So I'm going to have 1, 0 is the filler for the x cubed, negative 5, 4, and 12. And now the steps are going to be the same. You're still bringing down that first term. Negative 4 times 1 is negative 4, and add. Negative 4 is 16, and add. Negative 4 and 11 is negative 44, and add. And negative 4 and negative 40 gives me 160, and add gives me 172. And that 172 would be the evaluated form. That would be the evaluated value. If we did p of negative 4, there's the way I'd like you to write your answer. If you would plug in negative 4 to that polynomial there, your answer would be 172. Okay? So make sure you have your fillers, make sure you have your terms all in order here, and you're still just multiplying and add. Multiply, add. Multiply, and add. Okay? Let's do one more example. Good practice for synthetic division. Just another look at what the remainder theorem is. F of 3 equals 2x cubed plus 2x squared minus 4x plus 5. Okay, so I want to use the remainder theorem. So 3 is my a. No exponents, no values are missing, or no terms are missing, so we don't need any fillers. 2, 2, negative 4, 5. I'm bringing down my 2. 3 times 2 is 6. Add, you get an 8. 3 times 8 is 24. Gives you 20. 3 times 20 is 60. So f of 3 equals 65. Okay? So there's synthetic division and the remainder theorem, which uses synthetic division to evaluate. Okay? So that's the end of 6.4, so it'd be good to practice.